Hello and welcome to the Embedded C Programming Design Patterns course. This course is available here on YouTube, and also if you don't want to wait until the next module comes out, you can get this course as a book, as book plus videos, Udemy course, and also all of the book and video content, as well as live sessions with me on Wednesdays, which is available at swedishembedded.com. So the book is available on Kindle. You can download it from Amazon. The Udemy course contains the book materials as resources, as PDFs here. And on the website, we have the course available as a standalone course directly on the website. You just click join here, enter your details, register as a student, and then you will have access to all the course materials and also the weekly Q&A, which is in 5 days, 8 hours at the time when I'm recording this. All right, so let's get on with the next module of this course. Hello and welcome to another module of the Design Patterns training. My name is Martin Schroeder at swedishembedded.com, and in this module we're going to look at the callback pattern. The callback pattern is the primary way of decoupling our object that we are trying to observe from the observers that need to respond to events that are emanating from that object. If you have any questions regarding this training, I would suggest you join our Discord server. You can find the link at swedishembedded.com. And if you have any further questions regarding this training, you can always email me at martin.schroeder@swedishembedded.com. So let's get started. The defining characteristics of the callback pattern is that we have one object that is being observed, which is the object that's going to maintain a list of callbacks. And we also have a callback receiver, which is the object that's going to respond to events that come from the first object. And we want to decouple our object that is being observed from the object that is observing it, so that we get the full separation of concerns. So that, for example, if we have a button, we don't need the button to know of every single place in our software where we listen to button events. We can just add the callback pattern or apply the callback pattern to our button, and we can then register callbacks with the button and respond to those events in many different places potentially. So what are some of the use cases of the callback pattern? Well, it's a mechanism of notification, and it's one of those things that provide you with a way to send user data to the callback without actually passing an arbitrary pointer. So if you've been coding C for a while, you know that in many libraries that are written in C, you have this concept of passing user data from an object that emits an event to the object that listens to that event. And we want to avoid that because we want to make sure that our code is clean and type safe and that we have a standardized way of implementing the callbacks. So that's why we have the callback pattern. It's used to observe an object. So another name for this pattern is actually the observer pattern, but I call it the callback pattern because callback is such a central item in this pattern. And we're going to talk a lot about how we actually implement those callbacks correctly. We're going to implement them as structures. And it implements the one-to-many notifications. So we can potentially have a list of callbacks where we call all of them upon a particular event. So we get this implicit mechanism of one-to-many notifications without actually having to implement something like an event queue, for example. And the callback pattern is the groundwork for other more complex patterns. So for example, we can have a work queue, but that's a more complex pattern. We can have an event system where we can subscribe to events and broadcast them. That's another pattern that is slightly at a higher level than the callback pattern. The callback pattern is the simplest way of implementing this type of notifications. So we're going to cover this first. What are some of the benefits of the callback pattern? Well, we get decoupling. We don't need to depend on all of the listeners to our callback. We get the notification functionality. We get code reuse because we can have a standardized way of sending out those events, and then we can have multiple different listeners that respond to the same event. We get scalability because we can potentially have multiple listeners. We're not limited in the number of listeners we have. We get flexibility because we can have multiple different implementations of the listeners. We get also ease of maintenance because we only need to maintain the mechanism that broadcasts the callbacks, that basically loops through the list of callbacks and calls them. And we can also even abstract that away as well. But we get this, we achieve code reuse using every pattern essentially that we have in this training. All of these patterns help us to achieve greater code reuse. And here are some of the drawbacks of this pattern. So basically, we get a little bit more performance overhead because we are going to be delivering callbacks to many different objects. So we can potentially have this situation where we might have one callback take longer than we expect, and then all the other callbacks would be delayed because of that. We get a little bit higher complexity because callbacks always involve some kind of mechanism to register the callback. We have to unregister the callback, so we get a little bit more complexity. And we don't have control over the order of the notifications. So when we have a list of callbacks, it's the callers or the observers that decide when those callbacks are registered. And so we don't really have an order of, we don't really have a way to control the ordering of how the callbacks are delivered. We can solve this problem using more complex patterns, such as the work queue. We can have multiple priority levels for our events, but all of those things add to the complexity. So let's look at how we can actually implement this pattern. We start with this structure here. So all of our callbacks, and we can have more than one callback here, but all of our callbacks will essentially be placed into a struct, which we call, we specifically basically create a struct to hold all of our callbacks. And there is a reason for this, because we want to pass this callback struct to our callbacks as well, because this is going to be our primary way of getting the object that actually is supposed to respond to this callback. We can get a pointer to the observer by using this pointer here. And we can also make this, we can easily extend this structure to also, we can add a list item here, which will enable this structure to be arranged into lists. So in case we want to later create or add the functionality to our callbacks where we can have a list of callbacks, we can easily do that without modifying every single observer that uses this, this structure. And here's an example of how to do this. So let's say we're going to create an object called the button, which will emit an event. In this case, we're going to just emit the event when we call the button do something. And we want to be able to register callbacks with the button. So we can have simplest alternative is where we just keep the pointer to the callback structure. And the more complex alternative is that we keep a list of callbacks. So let's say we implement this structure and we also have our callback here and we have an API to this object, the button. And then we want to implement basically, this is the implementation of the button itself. So we have the add callback. In the simplest case, we just assign the pointer, and remove callback basically just removes that callback pointer. And then in do something, when it's time to emit this event, we check if the callback has been set, and then we just call the callback with the pointer to the callback structure. So far so good. If we want to implement an observer that listens to this callback, we would do it like this. So we have our observer structure, we have our button, which we're going to be listening on, and we have our callback, which is part of the observer implementation here, because we want this object to be directly embedded into the struct observer here. And the reason for this is because we want to be able to get the pointer to our observer structure like this. So we're going to use container off. Container off is a macro. You can look it up. It's a very simple macro that basically takes first the pointer to the callbacks, to this structure, and then it takes two other parameters which tell it where this structure is found. So in this case, this structure is found in struct observer. So we have struct observer here, and member CB. So in this case, it's this CB here. And when we call container off here with this CB here, which is essentially this pointer, we know that this pointer is pointing to this structure. So container off gives us the pointer to the observer. that we are operating on. So in this case, we get our self pointer using container of, and we can then operate on this self pointer inside our callback. So this effectively prevents us from the need of having to pass some kind of user data to our callback. And during initialization, we simply assign this this callback to the handler inside the CB pointer here, and we then call button add callback. So this interface is not going to change regardless of whether we have a list of callbacks or whether we just have one callback. So we can then easily extend our button to support a list of callbacks as well, which is something we're also going to do in this training. And upon the init, we need to remember to remove the callback. And this is one of the biggest pitfalls with the callback pattern, is that if you forget to do this, and your observer goes out of scope, for example, then the callback is going to be invalid, and you're not going to get any compiler warning or anything like that that would tell you that the callback is now invalid. So the only thing that will happen is basically that your program will crash. But that's a problem that you always face in C programming, regardless of what pattern you use and regardless how you structure things. There is basically no support in the C programming language to handle this type of ownership relationships between data structures. So that's something you need to pay attention to. And when it's time to use this controller or observer, we basically just create it like this, and we call our button do something, and then we basically deinitialize everything. So controller here is basically the same thing as observer in the previous slide. It's just that I didn't update the slide here. But this is basically our observer, and then we just call the button, and the button will in turn call the callback. So lastly, let's have a look at how we actually implement the scenario where we want to have a list of callbacks. The only thing we need to modify is the implementation of our button, where we modify our add callback method to add this callback to a list. And for list implementation, you can use any freely available list implementation. There is one in the Linux kernel. This one comes from the Zephyr RTOS, which is distributed under BSD license or Apache 2 license. So you can easily just take this implementation and use it in your software as long as you comply with the Apache 2 license. But the way this works is always basically the same way. So you have your list and you have your list node. And any structure that contains a list node can be part of a list. So basically you can just insert those nodes into a list, and then you can iterate through that list using a set of predefined macros. So in this case, it's sys slist because we're using single list, and we go through each node, we get our callback pointer, and then we just call the callback. And notice that when we do this, when we call it like this, then the callback itself is able to always resolve the enclosing data structure that corresponds to the object that is actually the observer of the callback. So this is very neat, and it's very little code. You can always create a macro that instantiates all of these functions to you as a template. And when it's time to delete the callback, we just call syslist find and remove. You can use also a double list. It takes a little bit more memory, but the double list doesn't require you to loop through all of the callbacks in order to delete one item. Since this one is a single list, slist, we need to find the item first and then remove it. So removal is a little bit more expensive because you need to loop through all of the callbacks. But on the other hand, the idea is that you wouldn't usually have that many callbacks. And actually, that's one of the problems with the callback pattern. When you get into that situation where you have too many callbacks, then you need to do other types of restructuring of your code. So that's it. That's very simple design and very simple implementation, and completely type safe, because we always get the correct pointer here, because we are assigning this function inside of our observer implementation. So this callback pointer here cannot be assigned anywhere else. It's always assigned inside the implementation, and so it's always the correct function here. So this will always return the correct result. All right, let's look at some of the best practices then of implementing this pattern. Well, number one is that you always should use the struct for representing your callback. And this gives you this both the type safety, but also the decoupling between all the callbacks that you have as part of that struct and all the code that uses the callbacks. Because when you have it as a struct, you can always add a new callback and not have to update every code that uses that registers callbacks with your callback provider. But instead, as long as you follow the object pattern and zero out all of your data fields in every structure that you initialize, it's always going to be safe to add another callback. And then as long as you check for that callback to be non-null before you call it, it's still going to continue to work. So making sure that the struct is a data structure and not just a direct callback is a very good practice to use when implementing this pattern. In fact, it's the only way to do it in a type safe manner, because if you define the callbacks as pointers, then you don't really have this built-in way of passing the address to the enclosing structure, and it becomes very messy because you basically just don't. You basically have to always be attentive to how you pass this data around. But when you make sure that you just embed this structure into your observer, then you can simply use the container off and get your address. So it's very simple. Always pass the context to the callback. That goes with point number 1. Avoid time-consuming operations in the callback, because every callback that responds to an event is going to delay all the other callbacks that also are waiting for that event. So keep that in mind. And there is no way in this very simple implementation of the callback to control the priority of all the callbacks that are registered. So anything that's going to be registered last is going to also run last. So you want to make sure that you don't have that you don't consume too much time responding to a callback anywhere. And always use container off. Don't try to get the address manually. Don't try to pass the data as a parameter manually. Container off is a proven way of doing this kind of thing, and container off is used extensively in both the Linux kernel and the Zephyr kernel, and it's implemented in such a way that it will work regardless of the architecture you're using. So it will always give you the right address, and it will always calculate the right offset, regardless of the alignment of the architecture, regardless of any other details. It's designed to work this way, and it's designed specifically for this purpose. And the common pitfalls of using this pattern. The biggest pitfall is by far the observer going out of scope. So you registered your callback, it's in the list, but then your observer goes out of scope. So now the list is invalid, and that messes up everything. So make sure that you always unregister the callbacks, or if you're coding in embedded systems, it's actually less of a problem, because usually you just register everything at startup and then you don't touch any of the organization of your objects. So your objects are always valid until the firmware reboots. But this is something to keep in mind. This is the biggest problem, and the compiler doesn't actually have any way of telling you that this will happen, because the compiler doesn't know. The C compiler is basically just not smart enough to identify those things. Don't make your data global. This is something that is very often used in conventional C programming that doesn't apply in design patterns, where you just have the data global and then you just call, you basically deliver the callbacks as direct function calls. And that's precisely the problem that we're trying to solve with the callback pattern. Don't pass the user data, always use container off. And keep in mind that if you allocate anything on the stack, then that object is also going to be destroyed. So very important that if you allocate the observer on the stack and you register some callbacks with another object, that you always deregister those callbacks before the object goes out of scope. There are 3 main alternatives to the callback pattern. The slightly more complex event bus pattern implements the publish subscribe mechanism, and this pattern actually decouples both the observer and the object being observed. So with the callback pattern, we decouple the object being observed. So the button doesn't need to know about all of the observers that listen to the events from the button. But with the event bus pattern, you decouple both of them. So now you can have multiple objects publishing to multiple topics, and then other objects listening on those topics and getting the events. So the event bus pattern is more complex, but it's also better at decoupling elements of the application. Model view controller pattern, it builds on the callback pattern, but here we have our model and the view connected to the controller, and it's the controller that becomes the mechanism of decoupling the model and the view. And the command request pattern is where you execute the callback as a data. So you pass a data structure. For example, you can send the data structure over the network, and you can have another object listening to that data structure, but that involves obviously parsing the incoming message. So it's kind of like the event system, but here you're just making the call as a data structure. So now you don't need to know who is actually handling the data structure. You just emit a data structure and it gets broadcasted to all of the listeners. But it's also more complex. So all of these alternatives are more complex than the basic callback pattern that we just described here. Great, so that finishes this lesson on the callback pattern. It's a rather short lesson, and hopefully you got an understanding of how and why we use structures to represent callbacks, how a callback pattern can improve your design through decoupling, and how you can retrieve user data in a very type-safe way from within your callback and from this callback structure pointer. Let's check your understanding of this concept. So what is the main problem that we are trying to solve with the callback mechanism? Look at some of the code you have right now, some of the existing systems you're working with. Try to identify where the callback pattern would actually make more sense than what you're doing today. How does the observer callback pattern help maintain object-oriented code organization in C? And object orientation is actually something that is universal to all programming languages. So even if C doesn't support object orientation through the language mechanisms, you still have to think in an object-oriented way. So object orientation is more about the philosophy of structuring code than about specific language features. Number 3, what would happen if you delivered the event using a direct call instead? So what if you just call the observer directly from your button? What implications does that have? Why are we always enclosing the callback into a structure? Do you remember that? So go back in the training and review the content so that you understand that. And why do we use a standard container auth macro? Well, it's standard kind of in the environments where we code on the Linux or on Zephyr. But if you don't have it, you should obviously take the implementation and use it as well. So why do we use this macro? What benefits does it give us when we use this macro to retrieve the context pointer, the self pointer for our observer? So that's it for this training, and I hope you learned something. I'll see you in the next module.